For probability notes, we're going to let A, B, C, etc., etc., etc. be an event that's going to happen. For example, getting a hit in baseball. That could be A. Now, if you ever see this, P of A, this means the probability that event A, whatever event is going to happen, it could be getting a hit, it could be flipping a coin, it could be doing anything like that. Flipping a coin and it landing on heads or landing on tails, that type of thing. Probably that event A happens. Now, mathematically speaking, the probability, put the battery pack back on. Put the battery pack back on. You guys don't get to take them out. That's not part of your job, is to disassemble the calculators. There are many ways to write this, but I'll write it like this. It's the number of successes, basically the number of times that A actually happens, divided by the total number of things that happen. So, for example, if you shoot 10 free throws, and A is that you make a free throw and you make 6, the probability that you make a free throw in basketball, it's going to be, how many did you make? 6 out of 10. So their total shots, that guy's your total shots, and these are your makes. So you have 6 out of 10, which is 0.6. So that means 60%. Oh yeah, take the earbud too. Red zone, you can't. You expecting a call? Well, you can't do that either. Now, odds. Odds of an event A happening. So this is going to be equal to now, this is a big thing. There's a huge difference between probability and odds. A probability is just how often something's going to happen. Odds actually compares the number of successes to the number of failures. Now, for our example above, you made 6 of 10 free throws. The odds of a make, well, how many did you make? 6. So you have 6 makes, and we need the number of misses underneath, which would be 4. And so those are your odds. And if you simplified it down, it's 3 to 2. So your odds of making a free throw are 3 to 2, which means for every 3 that you make, 2 you're going to miss. So it's a different way of looking at the same piece of information. So if you're talking about odds and you're talking about probability, you got to know that one is taking into account the number of things, the number of losses. If you think of an event happening and you think just in terms of wins and losses, A probability is the number of wins divided by the total number of things that happen. Odds are wins divided by losses. And we usually keep this as a ratio. Yeah, you can change that to 3 to 2 for your odds as well. A lot of times, hold on one second. A lot of times we actually don't even reduce things. Because if I keep my probability as 6 over 10, then I know that for this experimental situation, I made 6 and I shot 10. So that information is good. If I reduce this, it would be 3 over 5. And then all of a sudden, I don't know how many I made. I don't know how many I actually shot. And I don't know how many I actually made because I don't know that key piece of information. So you basically want to keep it as 6 over 10. You don't want to reduce it down to 3/5. Even though 3/5 would be correct, and if you did, I would mark it correct because it is correct. However, you lose information. Oh, you can as well. That's another thing that's correct. If you said this was equal to 0.6, that's correct. It's just you lose information there too, because then you have no idea how many shots you took, that type of a thing. Because there were 10 shots total. 6 of them were makes. So I had to have missed the other 4. Because to get the 4, that was 10 minus 6, which is equal to 4. Now, as we go through different ideas, and one of the ideas that we're going to go over today is we're going to talk about independent events. And as we go through this, we're going to have some different formulas. So probabilities of events that are independent of each other. Meaning, the outcome of a second attempt doesn't rely on the first attempt. A big example would be flipping a coin. And this is the best way. So as we're kind of going through this, when we're talking about independent events, you flip a coin, and it ends up heads. It's Canadian. So ends up heads. That was my first attempt. Now, because it landed on heads, is that gonna kind of, for the second time that I flip the coin, does that have any bearing on what happens the second time I flip the coin? No. So I flipped that, ended up being tails. Okay. Did that if I flip it again, did those two have any bearing? No. So that's what we mean by independent events. We just look at each one over and over and over again. The probability of independent events is going to be the probability of event A happening times the probability of event B happening. We just multiply your probabilities together times the probability of event C happening times the probability of event D, etc., etc., etc. You might only have 2 events. But this idea that we're going to multiply the probabilities together because they're independent of each other, that's a key piece of information that we're going to deal with today. Another key piece of information that we're going to deal with today Let me move this up a little bit. Expected values. Now, let's say that you have a 6-sided die. Here's the example. You have, well, let's say a 10-sided die. And we can make those. If you play Dungeons and Dragons, you do that all the time. There's 12-sided too. There's many sides as you need. So, now for a 10-sided die, let's say that 2 appears 3 times, 3 appears 5 times, and 6 appears 2 times. The expected value is what the probabilities tells us that we will get on a roll of the die or any other situation. Now, your expected value is going to be equal to, it's going to be equal to the value, for example, 2 times, what's the probability that we get a 2? Well, how many sides are there on the die? 10. How many of them are 2s? 3. So it's 3 out of 10. So it's the value here times the probability that you're going to get that value. And then I'm going to add that to the next one. For 3, what's the probability that I'll get a 3? How many times is 3 on the die? 5 times, and there's 10 sides. And now we have 6. How many times is that there? 2 times. So it's 2 out of 10. And then you'll use your calculators with this. So that's 6 out of 10. Since everything's out of 10, 6 plus 15 plus 12. That'd be 11. No, that's 21. 23. 2 times 6. Okay, that's 6. That's 15. That's 12. Yep. Oh, that's 27. You're right. 33 over 10. Which means we expect a value of 3.3. Now, yeah, we're not going to get 3.3, but expected values don't necessarily have to be the values that you get. But basically, on average, that's what we would expect, is to get a 3.3 out of this. Now, it makes more sense if you're talking about test scores and things like that. You could figure out different values, but it's always going to end up being the value times the probability of that value. And then you add up all the different values that you have going for you. So expected values, it's like you almost think of it as a weighted average. If you added up 2, 2, 2, 3, 3, 3, 3, 3, 6, and 6, and then divide it all by 10, you'd get your answer. And you'd get an answer of 33 over 10, which would be 3.3. So it's a way of calculating a weighted average in this case. So we're going to be dealing with these different ideas. So first off, questions on what probability is. Do you need down here or up there? All right, questions on what probability is. The number of successes divided by the total number of stuff that you've tried.
Is it a ratio or a fraction?
Yes. It's kind of treated as both. Conceptually, it's treated as a ratio. Mathematically, it's treated as a fraction. Odds, we don't do a lot mathematically with. Odds is strictly a ratio. So that's strictly going to be wins to losses, yeses to nos, that type of a thing. And the biggest thing is probability of independent events. You're going to multiply stuff together. You're going to multiply different ideas together. And expected values, we're okay with that? All right, so that's just the first part here.